Hello everyone. This lab we're going to do a delta to delta three-phase transformer bank connection and the calculations. So, same transformer. We have the same transformer, same ratio. The lab requires us to do parallel delta on the primary side, also parallel delta on the secondary side. So here's my connection. H1 for phase A, connect on line A. H4 for phase A connect on line B. Then H1 on phase B, connect on line B. H4 on phase B, connect on line C. Secondary side, phase A transformer, X1 on line A, X4 on line B. Phase B transformer from X1 on line B, X4 on line C. We still have 15 ohm each phase, but this time we connect low in delta. So I change the connection. Now the low 15 ohm resistor is connected in delta. Now we can do the calculation down here. Primary line voltage, 240 volts. Delta connection, so equal to the phase voltage. Secondary, the phase voltage, based on the transformer ratio, 2 to 1, so 240 volts divided by 2, give me 120 volts. Delta connection equal to the line voltage. I have a delta connected low, so the line voltage for the low, the 120 volts. Delta connected low, the phase voltage also 120 volts. Now I can calculate the phase current for the low. Phase voltage divided by resistance, 120 volt divided by 15 ohm. Give me 8 amps. Line current going to be √3 higher for the delta connection. So √3 times 8 amp, give me 13.9 amps. Total kVA for the low, 3 times E phase, I phase, give me 2880 VA for resistive of low. It's also 2880 watts. Primary phase current, I'm going to use the total low kVA divided by 3, divided by phase voltage, 2880 divided by 3, divided by 240 volt, which is the primary phase voltage, gave me 4 amps. Primary line current, √3 higher than the phase current, 6.93 amps. Same thing like we talked before, the low gonna deciding the current. It's not the transformer kVA. We're not gonna use 1.5 kVA, but we can consider 3 1.5 kVA give us 4.5 kVA. So our low only have 2.88 kVA. It's good for those transformer bank to handle in the low. But when we calculate the current, we're only gonna use the load kVA to do the calculation. We're talking about in the class, when we have a secondary is delta, we have to do a delta closure test before we finish the last jumper. I'm going to show you on the board there how we're going to do it. But here is, when we connect those 3 phase transformer right, so one phase go here, another phase go here, third phase, we will finish the triangle. So if I use a voltmeter, try to do the closure test, I should read about 0 volts. But if I connect one of the transformer winding wrong, so one go here, another go here, the third one, or you don't have to connect the third one wrong, any of them wrong, instead of this phase voltage go that way, this one will go to the opposite way. So when we try to use a voltmeter to do the delta closure test, instead of reading 0 volts, from here to here, we're going to read twice the phase voltage or twice the low line voltage. I'm going to read 240 volts because secondary line voltage is 120. So I'm reading 240 volts, double the secondary line voltage. That's when I connect the transformer wrong. So here the calculation, I'm going to go to the board to show you the real lab.